Well, now let's turn to our 3D CAD build along with Earl Hackett. Earl, welcome.
Hello there. Broadcasting from my son's office here. So if you look at my name, it says Chris Hackett, not so. Don't get confused. The last presentation had a little computer failure, and then I got all confused, and I picked up the wrong dimensions on the drawings. That was a bit of a mess. So I went back and I corrected all that. If you go back and look at the posted video from that week, it's all fixed, and you'll see how it goes. This week we're doing the cross braces, and this is by far the most difficult part of the whole thing. But it's nice that it's the last part of the whole thing. The actual amount of time I took to, I always rehearse this myself before I try to show it on NewTracks. It was about an hour and 15 minutes for me to construct these things. That's a little long for one of our segments. So most of it was repetitive stuff that you've seen many times before. So there's no reason for you. I just skipped over all that stuff that you've all seen before. And I made a video of the shortened section. It's still 20 minutes long, but it shows two different methods for accomplishing this task. If you could roll the video, we'll look at it, and let's see what we got.
Before I get started tonight, during the last presentation I had a computer failure. That distracted me and errors were made reading some dimensions. These have been corrected and have been posted in the August 11th segment of this series. View that segment before trying to tackle this portion. This is by far the most complex part of the build. I'll show two ways I approached the problem of modeling these braces. There were many attempts that didn't work, and I had to back out of them and try again. Thus, there are several points in the video where there are sudden changes in perspective. If I showed all these dead ends, the video would be easily over 2 hours long. This is what I call a shadow part. On the prototype, it's a steel angle brace, but for added strength where it's not easily seen, I'll fill it in, but it still retains the visual appearance of an angle brace. In the lower left of the screen, you'll see a display that shows all the keystrokes as they are entered, something you don't get in a live presentation. For the lower braces, I'll start by creating a surface based on the dimensions taken from the beams to which the braces will be attached.
You can see the length is at the bottom of that little pop-up screen.
This surface is strictly for setting up the dimensions for the braces and the gusset plates. It'll be deleted later on. So this is where we're actually forming the plate. We're going to draw it based on the dimensions that I just took.
You'll see the method to my madness in a few moments.
Now we're just going to extrude it to some thickness so we have a solid to work with. The first step is to create the gusset plates. You've seen these actions many times before, so I won't make a comment until we get to something new. This is the gusset plate. We'll dimension it out to 6 by 6 millimeters. And extrude it. Now I'll just copy it to the other side, other corner rather. Now we're going to prepare the brace itself. I'm going to draw on the surface of one of the plates there. And we use the that angled rectangle tool. And again, we'll extrude it here just to make a 1x1 bar, 1 millimeter bar. And move it so that it's lined up with the midpoint on the corner of the gusset plate. Thicken is a useful tool. You can stretch or shrink a single face of a part. The default was 5 millimeters. That was close enough. Chamfering a rectangle was a lot easier than drawing the desired outline. You just select an edge and enter how much material you want to remove. So that's one of the braces completed. We'll make the other one by just mirroring the this one. The box on the surface is just a way to get a perpendicular surface at the center of the construction surface. After joining the three parts of the cross brace, I can use the center surface to mirror the brace to create the second brace. The two braces are joined, moved into position, and made into an array to complete the lower bracing. The girder panels are 14 inches wide. There are 3 of them, so the spacing for the cross braces is going to be 42 millimeters. And there's going to be 4 of them. I'll make another construction surface to build the upper braces. Could have done this with a rectangle, but I just did it with lines. You can see the reason for using these construction plates is so that you can get clear access to the surface that you want to build on. Trying to construct the lattices or the braces down inside all this other stuff would be very, very difficult. You'd be constantly looking for an angle so you can see what you're doing. Gusset plates are made just like those for the lower braces. To save time, I'll just skip over most of this. Made those equal, so I only have to dimension one. It's a square, but we're not looking at it straight down, so it doesn't look square, but it is. I just move that to the midpoint. Since the upper braces are concealed under the ties, I'll just use a square section to construct them. I'll create an extra long brace and move it into the center position. When I got all done with this, I realized that they're going to be upside down. You're not going to see them at all. So, yeah, I really wasted a lot of time fooling around with this, but it does demonstrate how to position them more accurately. This line just provides an axis of rotation. Next, I'll rotate and crop the center brace to form the diagonal brace. The 43.5 angular rotation was determined by trial and error, and it took about 5 times to get it right. The system wouldn't accept negative angles of rotation, so rather than doing the math, I just mirrored the angled brace. Unfortunately, the only surface I had for the mirror was the side of the central brace, so I had to correct the diagonal brace's position. The thicken command is sort of helpful because you could also shorten parts. Now they're all joined into a single piece. I created these upper braces from the top view, so we have to invert them or mirror them so they're facing the right direction for assembly. Once the top braces are arrayed and joined to the rest of the structure, the bridge is essentially complete. I'll leave it to you to add the pedestals on which the bridge rests. There are plenty of images for these structures on the internet, so you shouldn't have any trouble finding a prototype. There are a lot of details that I didn't include in this bridge construction. At the end of each floor beam are a pair of 6-inch angles to bond them to the girder plate. And at the end of each stringer, there are another pair of 6-inch angles to rivet it to the floor beam. In addition, there's a 6-inch angle under each end of each stringer to support it. So putting in all that stuff would have taken a huge amount of time, and I just didn't see it was really, this is an instructional video. I'm not building a contest model here. It's also a bunch of rivets that I didn't put in. So if you're building a contest model, you may want to put a little more effort into it. The next and final installment, I'll download the STL file, show how I approach setting a model up for printing, and finally print the model and clean up the supports. Okay.
All right. There was a lot of stuff there, and I hope I didn't go too fast for you. But what I'm trying to show is the not so much how to use this particular CAD system, but how to think through the stages in which you would build a structure like this. Because it's when you look at it initially, if you've never done this before, you say, well, where the heck do I start? And I hope I was giving that's the primary thing I wanted to give you insight into is how to start breaking it down into the pieces and how to build each part and extend it and fit other parts in as necessary to complete the model.